Good. Yes. There we go.
Awesome.
Works. Okay, I will go mute.
Sorry
and
about
then,
that.
Yeah. So I will go mute, and then once you go to Q&A, then I will enable again. Okay. Go for it.
Okay. Thank you. Thank you, everyone. Thank you, Luca. There was a small hiccup expected when we are doing some remote. um, so I'm bringing the user. So I'm Vasudev Gulapalli, work as a senior staff engineer manager at Qualcomm. I manage various Git products in a way at Qualcomm, which is GitLab, Gerrit, GitHub, GitLab. I'm the platform owner. So I may give you the uh, user experience in a way from being an SRE, being an DevOps guy at Qualcomm. With that, let's start. Okay, this is the agenda. Gerrit landscape at Qualcomm. We built some AI-based code review system. We'll quickly go over it. We are experiencing some load constraints nowadays with the increase in number of use cases, particularly coming from AI domain. How are we coping up? What sort of JVM tuning we did and changes to garbage collection? What sort of bottlenecks we ran into from storage perspective? Going to emphasize on that a little bit more. I may brag about online upgrades 3.9 to 3.10. It's a huge differentiator, I would say, from a Gerrit perspective. Operations-wise, with the AI boom, there is some lot of AI initiatives going on in Qualcomm. We built some runbooks. I have one use case which I can go over. And then finally I'll wrap it up with challenges and future opportunities. Landscape. So Gerrit is huge, like as Tony mentioned, contributing to Gerrit, because a lot of Android-wise or any auto-wise flagship devices-wise, Gerrit is being used across the board in Qualcomm and many other innovative companies out there, right? So contributing to Gerrit means, in a way, directly or indirectly, you're contributing to these flagship devices, which are serving auto industry, IoT industry, smartphones, you name it, right? So please continue doing what you're doing, open source community-wise. With that, Gerrit is huge in Qualcomm. We are talking about 15,000 active engineers using Gerrit. Obviously, if we add service accounts, bot accounts, that number will significantly grow, right? Due to proprietary reasons, I mentioned, instance names as A, B, C, D, and other instances. The focus primarily for this discussion, because of the time constraint, I will let me use a pointer. So I'm going to use instance A to explain what sort of landscape we got. Instance A, as you see it, it's the biggest installation in Qualcomm, and it is serving Android market out there. As Tony mentioned, 2008, Google, Android, Qualcomm is heavy into Android space, so connect the dots. Instance A, we are talking about, we have 7 primaries HA, high availability wise. Each primary is about, I'm hearing the echo, sorry. Each primary probably we are talking about 500 GB RAM. It's beefy ones, I'm giving an example. So 7 primaries and we have 14 global replicas. Sites-wise, right? Each replica can have like 100 pods to 1500 pods, and each pod memory request-wise probably 30 GB. So you scale it. We're talking about a heavy installation here. Storage-wise, we are NAS customers primarily. Primary-wise, we have a 13 TB disk used. Replicas wise, as the math adds up, it brings around 200 MB. This instance alone has 12,000 active users, active Gerrit engineers working, active Qualcomm engineers using it. Writes wise, we're talking about 7 million per month at least, and it is growing significantly nowadays. And reads wise 150 million per month. That is the volume we are talking about. So any interruption to the service, we are talking about a direct impact to the critical flagship devices or their corresponding launches or releases. So it's a pretty big deal. Let me talk about what we did from AI-based code review system, which we developed this year with Gerrit. This is the workflow I'll go through one step at a time. So let's assume that there is a developer and he pushed a path set to a Gerrit instance. The change has two files, a.py and b.py. We have a webhook plugin integrated with the instance with the corresponding webhook config. The path set, so because the change was pushed, path set created event has been triggered. And we have an AI plugin, which is in-house plugin, which we developed. It gets that event through HTTP as a request. And then what it does is it gets the event AI-wise, plugin-wise, and then it starts talking to the primary, the Gerrit instance-wise. So it asks for, hey, what is a patch? Give me all the current files. Give me this path set for both the files. All these GET requests are initiated by the plugin, and the primary is responding with the requested details. And then we have another AI code generator as a separate entity, which looks at the AI plugin, sends this information to the AI code generator, and the feedback is sent back from that. Then comes then the AI plugin. In this case, Gerrit instance triggers, hey, do you have the data which I requested for? It generates that request, the AI plugin wise, and then once the data is there, it sends a feedback saying, hey, I got the data, consume it. Then we have Gerrit on the change itself. The checks tab will populate with all the code review comments. We are not using the actual Gerrit code review comments. Rather, we are using the checks tab because it is because the bot system, it is designed in that way, and also due to legal constraints on having AI-based code reviews and all. That's another reason why we went this approach. In a nutshell, we are talking about right now 600 plus repositories have been onboarded. It is going pretty fast. Similarly, as I said, the load we are talking about, it's very chatty now. 200,000 requests are being accounted so far. Very chatty. We are trying our best to optimize it. Along with it, we are looking at ways to scale the system or any tuning optimization opportunities we have. We are applying them at the instance level. Some of the challenges we faced as we are doing the repo onboarding or the project onboarding into the automated AI-based code review system, the refs meta config has to be touched, and we are ensuring that because it's a very key component. We need to make sure only owners or elevated people only can touch that area to make any of the changes as part of the onboarding process. So there are some checks and balances in place to reduce the operational cost. We ensure that only the people who are owners can do activities like onboarding the project into AI system. Along with it, we encountered a flood of webhook events because all the events are allowed through webhook configs. We want to manage it, we want to control it. We had a brief, I don't want to say the service interruption, but it went to a bad state because one of the projects were onboarded in an incorrect way. So right now there are a lot of checks and balances around it to ensure that we are not going to run into a similar situation. That comes, if you look at the trend, load is being increased a lot. So how do we scale it, right? Is there any opportunities? That's where we looked at JVM tuning, heap sizes wise, XMX wise, is there any opportunity there? OS wise, is there any opportunity? Along with those GC wise, is there any opportunity? So in the last year's Gerrit User Summit, we realized that ZGC is something interesting to explore, and we went with that direction. Very promising. If you look at this table on the top, this was our baseline, production baseline. We had Java 17 running with GC as parallel or GC. This was the throughput with the time box testing we did. We quantified it. What was the throughput? What was the max latency? And transactions wise, this was the baseline. So that was we captured all these data, and then one variable at a time we changed it. Now we're talking about Java 21. The rest all remained the same, and these are the indicators. We saw some increase in the transaction count. That means, as I said, it was time boxed. So how many transactions, a successful transaction Gerrit can handle during that time box? Is there any increased number of transactions that Gerrit can handle? So we just saw a slight increase. So with one variable change, Java 21 in the picture. Then we continued that, made some changes to the GC. We brought in ZGC, and these are the numbers. If you look at it, huge bump throughput-wise, 94 to 99. Latency-wise, we are talking about milliseconds now, from seconds, 0.1 to 1 millisecond. And the transactions count was also a good jump, I would say, 2% jump. That was good enough for us to go ahead with the ZGC. We went with that. Things are working great. But during the process of actually, one thing which I want to highlight was, or low light was, during the testing phase, we ran into some JVM crashes. Max map count, which is the default value coming out from the OS side, was not tuned, was not touched because we didn't realize it, that ZGC needed that change. During testing, when it was crashing and all, we read a few articles and realized that, this has to be bumped. So right now, production, it is at the value of 1 million. So things are looking good. And then the increased memory consumption is another one which we are running into, though it is somewhat noise from operations team perspective. But we are looking at native memory consumption, and particularly around GC threads. Is there anything which we can optimize further? But FY26 wise, we are looking at upgraded systems, increased RAM from 5 GB to 1 TB. No, that's the projection which we are looking at, just to be safe, as well as address any increased load coming into the picture. Then comes the bottleneck on NFS side. As we know, Git and NFS version 3, we are at version 3. We're not using version 4.1 or 4 still because of obvious reasons. But NFS wise, we are struggling. We struggled a lot. We try to address it. The previous architecture for one of the critical sites was both the primary and the replica are consuming the same backend filer path, NAS wise. So primary was struggling. So with primary being struggling, we are talking about the instability across the board. We have seen sometimes when the duplicate changes were created because of NFS caching inefficiencies. So in order to address that, we split the simple action is, okay, primary can be primary and replica should be, separated out. So we took that immediate step. It was handy for a while, but still again, the growth across the board, repos are growing, users are growing, use cases are growing. So we are seeing some more degraded performances, particularly on few sites where the user base or the user consumption is relatively much higher. So then we started exploring other products, NetApp wise. Is there any other product? Again, because of that AI boom, VAST stood out. They have improved NFS workflows. So we deployed VAST in one of the sites. So one replica site we divided into two again. One is running with NetApp and the other one with VAST, so that we can do a blue-green deployment at some point. That's a strategy there. VAST-wise, it is showing better performance at this point. But I don't want to call it as apples to apples comparison yet, because NetApp still has a lot of user base than VAST, because we are doing it a phased approach. So far, it is looking good. We are going to do a phase 4, phase 5 release soon. Then we'll know whether VAST can cope up with the increased load. If it won't, then we have a backup plan where there will be a load balancer on the top, and we are going to split the load in a way so we don't run into similar issues in future. Then comes online upgrade. All Gerrit instances, if you not sure how many of you joined the last year's Gerrit user summit, there was a technical debt on our side, upgrade versions wise. Right now, all Gerrit instances are running on 3.10. For us, it's huge. So our user community can consume latest and greatest features, which you guys have. The main, as I said, I deal with various Git-based SCM systems like GitHub, GitLab. I don't want to brag, but this major upgrade like Gerrit 3.9 to 3.10, zero downtime was achieved, right? For enterprise installations like this, it's huge because there is no downtime for our user community. At Qualcomm, getting downtime is hard when we are talking about global presence, when we have increased number of launches. Thank you. This is great. Finally, as I said, I'm going to show you guys one use case where we are predicting AI runbooks like integrated together. We are predicting how the users behave from primary consumption wise, in the sense, if a primary is being used to do some read operations like fetching, cloning, they don't really need to do that. We have replicas present across Qualcomm on almost all the data centers, so they can go to the nearest replica and get the data from there, clone the repository from there, right? So that was the use case where we realized that, okay, let's invest in time there. Stability of primary is much more important than anything else to have the whole application to be in stable state. So this use case was designed so that prediction will happen, runbook is designed, so without a human intervention, the client traffic will be rerouted from primary to the nearest replica. If human intervention is needed, if for some reason the runbook execution fails, right? That's when it will escalate to the on-call bot, and then the engineer comes into the picture at some point. Finally, challenges. H2 cache management on primaries particularly is still a challenge. It is growing. The significant growth from disk consumption wise is being a big problem for us from H2 wise. We want to consider distributed caches. We are looking at Redis as one of the distributed cache solutions. That's one thing. There are some NFS issues of, NodeDB, when multiple primaries are trying to write something to the same NFS backend. We have seen some issues. We have not seen corruptions to an extent, so we are okay with it to deal with, but it is still a problem. As I emphasized, increased load is another challenge. So we are looking at ways on how we can address it, whether vertically. So far, we are horizontally auto-scaling the pods. We are looking at vertical scaling as well. Along with it, right now, clones only can take, replicas only can take clones from SSH based. So future is looking at HTTPS because there are some other use cases which we want to address through HTTPS. With that, thank you so much for this opportunity. I really appreciate that. I love Gerrit. That's why I woke up at 4 without an alarm. So I'm listening in to most of the tech talks. Thanks for this opportunity.
Okay, thank you very much, Vastev. Any questions? Okay, so it's going to be tricky because first, you don't see the people in the audience, and then even worse, let's say you don't hear the questions, right? So I will give the microphone to the person, and then I will come closer to the laptop, will repeat the question. Okay, 1 second. Who wants to go first? Okay. No, there we go.
So on the page that you mentioned about the Java upgrade, you it is there that you used to use parallel GC. Do you have any data, or if you even used G1 GC to see what is the difference between those two, the ZGC and G1 GC?
Did you hear the question?
We did. I heard the question,
okay,
Luca.
Good.
Can you guys hear me? Okay.
Okay, yeah, go for it. Can you answer?
Yes, we did not do testing on G1 GC. We jumped on ZGC because the Gerrit user community is already encouraging folks to use ZGC. So we went with that and we saw promising results. So we took that route than testing on G1 GC.
Okay, other questions? Can you get the microphone? Yeah, thank you.
Yes, you're using GitHub, GitLab, and Gerrit. Why not just Gerrit?
Okay, did you get the question? Yeah, go for it.
So each business unit, so Qualcomm is primarily engineering-driven company. So the VPs or the business units take a call on what toolkits they want to use. Due to legacy reasons, we have GitLab, and I think it is going to continue usage-wise, not organic growth, but it is going to continue. From GitHub side, we have some other use cases where due to M&A reasons or the customers, the auto customers particularly, we are working with, if they are already using an SCM system and in a way we are with it, using it. It is not because of user community, like in the sense, hey, I love Gerrit, I love GitHub, I love Gerrit, GitLab. That's not the reason. Rather, it is a business reason on having multiple Git instances. Being said that, I think the Gerrit platform is so huge in Qualcomm. Moving away from Gerrit is not an option at this point.
Okay, more questions? No, can I actually get the microphone and ask a question to you? Okay, so one thing that was really interesting for me is what you showed, that basically you have integrated AI into your software lifecycle. You explained also how you did it together with Gerrit. I'm sure that lots of other companies did the same, not just on Gerrit, but also on GitLab and also on GitHub Enterprise, right? So can you raise your hand if your company is actually done this type of integration with AI or is planning to? Good. And do you see that happening also on other SCM, not just Gerrit, but also GitLab? Do you see the workload being increased because of that AI acceleration?
Yes. Yes.
Okay.
Yes.
Do you have any plans? So, because I believe Vazdev was actually saying that they're looking at horizontal scaling for solving that problem. And what is your plan, if you have any plans?
Horizontal scaling.
Horizontal scaling?
I mean,
Okay.
that would go into way too much depth now to talk about that. That would take another half an hour.
Okay. I just wanted to say that tomorrow, actually, I'm going to talk about those two topics. So there's going to be a talk by me talking about what is the status of AI with Gerrit, because Vazdev has shown one way, but Gerrit is good because there are 3 million ways of doing the same thing. So I'm going to show not a different way, but a kind of overview of different ways of doing it. And also I'm going to show about a way that is different from horizontal scaling for being able to tackle the increase of load on AI. Because the problem with the horizontal scaling, I believe Vazdev highlighted a little bit, is that you can scale the cluster, but at the end of the day, you rely on the shared NFS, and that is going to be your bottleneck, right? If you don't rely on shared NFS, of course, that is going to work. But then you got other challenges if you work with monorepos. Because if you work with monorepos, then, of course, then you need to be extremely careful of what you're doing because you may end up in split brain or something. So I believe we can continue tomorrow that conversation. We're taking some recording of your presentation. Can you authorize me to take just a few minutes of your talk and replay to the audience tomorrow? Because that was really
Absolutely.
good. Because when I talk about that problem, people say, oh, come on, nobody's doing that. And your one was really great because it's a real testimony of a company that actually is doing it, right? And so those problems are real. Okay, thank you, everyone. And see you tomorrow. I just wanted to call for a round of applause for little Martin that managed the YouTube video all day. So a round of applause for Martin. Well done. And I got feedback from people watching on YouTube, but they will say, oh, who is doing the YouTube live stream? That was great. Yeah, all perfect. Thank you, guys. See you tomorrow.
Thank you.
Okay, and plans for dinner.